Welcome to this video on arithmetic sequences. In this video, we're going to do a couple of examples of arithmetic sequences. Before we get started, make sure to subscribe if you haven't already and to turn on the notification bell to get notified when I upload a video. So, this is a basic terminology you need to know in this topic. So, a sequence is a succession of numbers which are arranged in a specific order according to a rule, and a term is each number in a sequence. And the common difference is basically the difference between two numbers. And the general term is an expression of variables and constants, usually referred to as a rule. Okay, moving on. So, a general term. So this is basically your general term in an arithmetic sequence. And it's basically telling us that let's say the nth term is equal to a, which in this case is the first term, plus n minus 1 times by d. Okay, when n is basically your term, which is subtracted by 1, times by the d, which is the common difference. So your common difference. Okay, moving on. So the question is, find the first term and common difference of each sequence. And our sequence is 7, 9, 11, 13, 15, and 17. So the first term is basically what comes first in your sequence. So the first thing that you see in your sequence. In this case, a is equal to 7. And d, which is our common difference, is basically the difference with our first term and second term. But in some cases, we can also consider finding the third and fourth term, because some cases you could be involved. You could be given a quadratic sequence, which we will not do today because that's for a different time. And so it's sometimes a good idea to check for the first and second term and third and fourth, just to make sure. And d is equal to 2 because the difference with 7 and 9 is 2, and the difference with 9 and 11 is also 2. And this common difference is carried on throughout the whole sequence. So, therefore, d is equal to 2. And now for our next sequence, it's 3, 0, negative 3, negative 6, negative 9, and negative 12, and so on. So same thing, find the first term. So first term is 3, straightforward, a is equal to 3. And d, which is your common difference, is minus 3. 3 minus 3 is 0, so that equals out. So minus 3. Okay, so now, find the general term a of the following sequences. Okay, so what it's basically telling you to do, we're doing the same approach as the previous two questions, except you have to find the general term, so it's a step after. Okay, so basically our sequence is 2, 6, 10, 14, 18, and 22, and so on. Okay, so the first term is 2, and so that's 2, and then common difference is 4, as it's increasing by 4, our sequence. And now, a step further, we're just going to bring in this rule into our question. So we're going to use this rule, but the only difference is that we're going to substitute what we have here. So a and d is going to be substituted with the value. So a is equal to 2, so that's 2 plus n minus 1 times by d, which is 4, and therefore 2 plus, we're going to consider this like algebra because you've got a variable and you've got a number on the outside, so you multiply. So you're just going to go n times by 4, which gives you, so that's 4n, and then minus, and then we go minus 1, so minus 1 times by minus 4, which gives you minus 4, and now you just rewrite as 4n minus 2. So, and you can also check that this is correct if you take these terms and substitute them, and whatever the term is equal to, then you can tell it's right. So I'll do an example. So this is your first term, second term, third term, fourth, and so on. And so if we take the first term and substitute it with n, which is what the term means, so the number of term, so it's 4 times by 1 minus 2. So basically what I'm telling you is, so we're taking the first term here, and as a result, if we get an answer of 2, if we get 2 as the answer, therefore our rule is correct. And you can keep this pattern going for each number. So if you take 2, if you substitute 2, your outcome should be 6. So it's basically like an x and y input and output. So therefore, 4 times 1 minus 2, that gives you 2. So therefore that's correct. If we put in 1, as a result we get 2. Okay, so that's correct. So our rule is 4n minus 2. So moving on. So the first term in our sequence is minus 14 in this one. So it's minus 14. And d, in this case, is your common difference, which is actually plus 2. So in this case, our sequence is increasing by 2. Okay, so now we're going to use our general term. So an is equal to, so our first term, which is minus 14, plus n minus 1 times by 2, therefore minus 14 plus, same thing as what we did here, n minus 2, which is 2n, minus 1 times by 2, which is minus 2, and as a result, when you rearrange 2n, minus 14 and minus 2 gives you minus 16, therefore our rule is 2n minus 16, and we can do a quick check. If we substitute our first term, if we get minus 14, our term is correct, our rule is correct. So 2 times by 1 minus 16, then you get 2 minus 16, and as a result, minus 14. Therefore, our rule is correct. So moving on. So this is quite hard now. So moving up to the tricky bit. So find the first term, a, and the common difference of the arithmetic sequence. So in this case, we're missing 2 components in our sequence, in this arithmetic sequence. So basically, we have to look for the first term and the common difference. So it's not just one thing missing, it's 2 things missing. But we're given more of a help because we're given more information. Okay, let's start. So basically, how do you start this? So the first thing I like to do is to write down, so I would like to have the general term out next to me just to make sure. So just like as a guide, so an is equal to a plus, just make sure, so n minus 1 times by d. Okay, that's the rule we're going to follow. Okay, so an is basically telling you what is your term, and in this case we're looking at the 6th term, so we rewrite it as a6 because it's telling us it's the 6th term is equal to a, so that's our missing thing because we don't know the first term here. It's because in our question it's telling us to find, so we leave it as a plus n minus 1. So n in this case is what I said before is our term. In this case it's 6, so we put it as 6. So 6 minus 1 times by d, which is what we're finding, so we leave it as d, and this is equal to minus 25. So whatever your term is equal to, you just put in there. So minus 25. Minus 25. Okay, and now a for the next part is equal to 16. So we're looking at the 16th term. So that's equal to 16. And then a plus, I'll do that again for you. Okay, so at this point you just have to take 16 and we subtract it by 1. 16 minus 1 times by d, which is 35. And you can, at this point, you can treat this equation as a simultaneous equation. If you don't already know a simultaneous equation, make sure to look at that video I've made because it's really helpful for this part of this video. Okay, so using the same approach to a simultaneous equation, we're going to number as 1 and 2, and I'll rewrite this for you just so it looks better because I don't think it's. I'll rewrite this part. Okay, let's write it as 5 and 15 as a reduced form. Okay, so now we're good. So now, at this point, we're going to go equation 2 minus 1. So we can cancel out what we need. So we can cancel out the a, and we'll be left with d, so we can find d. Same approach to a simultaneous equation. So 15 minus 5. So we're just going to go equation 2 minus equation 1. And 15 minus 5 gives you 10. And that's obviously times by d. This is it's like connected, so to be 15d subtracted by 5d. So 15d subtracted by 5d. That's what I'm trying to tell you. Okay, so that's equal to, and by the way, the a's have cancelled out because a minus a gives you nothing. And now 35 minus 25. So I'll write that down for you. So that's 35. So that's minus 25. So basically that will give you 35 plus 25, which gives you 60. So that's 60. Okay. So that part is equal to 60. So 10d is equal to 60. Therefore, we can just divide by 10 to get rid of the 10 from the left-hand side. And you're left with d is equal to 6. So your common difference, therefore, is equal to 6. And now, we substitute d is equal to 6 into equation 1. So sub d is equal to 6 into, so that's into equation 1. So into equation 1. Okay. So we replace whatever d is with 6. So a plus 5 times 6, which is 30, which is equal to minus 25. Minus 25. And when you rearrange this, a is equal to minus 55. So minus 55. Okay, so now a is equal to minus 55 and d is equal to 6. And therefore we found what we need to do in our question. So d is 6 and a, which is minus 55. And from this information, now we know that the first term is minus 55. So first term equals minus 55. And our common difference, CD, which is 6. Okay, so moving on. Okay, so the next question is, find the seventh term. The seventh term is 4, and the 18th term is 70. So we have to find the first term a and the common difference, same exact thing. So now, a is equal to 7. I'll write that in black. A is equal to 7, which is equal to a plus 7 minus 1, which is 6. 6d, which is equal to 4, which is what our term is. And that's going to be named as equation 1. Okay, and then the next part is a is equal to 18. The 18th term is equal to a plus 17d, which is equal to 70, and that's going to be equation 2. Okay, so now, with this information, we're going to go equation 2 minus 1. So equation 2 minus 1, and 17d minus 6d gives you 11d. This will be equal to 70 minus 4, which is going to be 66. And then we can divide by 11 to both sides, and that will give you 6. D is equal to 6. And now we can sub D is equal to 6 into equation 1. And as a result, it'll be a plus 6 times by 6, which is equal to 4. And a plus 36 is equal to 4. And then a is equal to 4 minus 36. Okay, and then now give you as a result, a is equal to minus 32. And therefore, our first term, so first term is equal to minus 32. And our CD is equal to 6. So hopefully you enjoyed this video on arithmetic sequences. Make sure to subscribe and bye.